Well, let's solve for this side AC. First off, it's a right triangle with a 45 there. That's sufficient for you to see this. It's a 45, 45, 90 triangle. You recall the ratio of the sides, 1, 1, square root of 2. Some of you like x, x, x radical 2. I think this is easier. Watch this. Whatever this number is, if I'm going from here to this side, I'm going to divide by radical 2. Okay? So this side is going to be 7 divided by radical 2. But as we all know, we have to rationalize the denominator. And you know how this works out. Radical 2 times radical 2 is the whole number 2. So it's going to be 7 halves radical 2 right there, C. Well, I have this overall square tile with a series of these 4 45, 45, 90 triangles, which of course makes this a square itself. Pretty neat design. This is 2 radical 2 inches here. We're looking for this. There's our ratio of the sides. I could say 1, 1 radical 2 or x, x, x radical 2. So clearly, I'm going to take this. Now, if this is here, then each of those x's, of course, simply 2 inches. Well, let's fill in the blanks here using our ratios of this triangle. And these will be sides A, B, and C for our 45, 45, 90 triangle. Well, of course, we know the ratios. We could use the x's, but I like this. 1, 1, radical 2. Let's go for the first one. In the first case, we're working vertically here. If A is 1, if A is 7, then B is 7. And C must be 7 radical 2. 7 and 7 radical 2. I think you all got that part. Okay, the second one's easy too. Because after all, if this is 11, so is this. Oops. That's this right here. And the hypotenuse is 11 radical 2. The next one gets more interesting. Let's suppose this side is the 10. Remember what we did in class. We did this exercise. The ratio is radical 2 to 1, or say radical 2 to 1 from C to A. So instead of multiplying by radical 2, I'm dividing by radical 2. The exercise we did it looked a lot like this. When I divide by radical 2, I have to rationalize the denominator, multiplying by the square root of 2 over 2, and that meant that I could divide out this common factor here. 10 divided by 2 is 5, so that gave me 5 radical 2. Do you remember that now? Okay, maybe I'll just leave that there in case you want to see it. Now, the shortcut that we'll get, whatever this is, if you're dividing and then rationalizing, dividing by radical 2 and rationalizing, just take this C, 10, half of it's 5, so this side's 5 radical 2. If this were 40, 20 radical 2. 66, 33 radical 2, and so on. So now, you'll never get stuck on that one again. And of course, B is the same as A. Now, next one, pretty straightforward. And again, I'm going from here to here. I'm dividing by radical 2. 6 radical 2 divided by radical 2 is just plain 6. That'll be true for A. That'll be true for B. So, look at it this way. 6, 6, 6 radical 2. Now the next one's a little funny. Radical 5. It doesn't have to have a radical 2 in it. So this is all we're going to do. First off, A and B are the same. So if this is radical 5, take radical 5 multiplied by radical 2. What do you get? That would be radical 10. And there you go. Completed the table in simplified radical form. Well, I've got 2 isosceles right triangles here, and let's show that they're similar. Well, the easiest way is going by their other name. They're called 45, 45, 90 triangles. And we know that because, again, the base angles of an isosceles triangle are congruent, and they have to add up to 90, so they must be 45 each. Therefore, the triangles are similar by angle-angle similarity postulate. Now, the other way we could do it, well, let's suppose I did this. I'm going to assign a variable here, g. This would have to have a different value, call it k. Well, that means the other ones, this would also have to be g, and this one would have to be k as well. Since these are, after all, isosceles, I could then say, since the right angles, that is, these two angles are congruent, right there, are congruent, and that the ratio g is to k as g is to k demonstrates to me side-angle side similarity. Well, let's prove this theorem of the 45-45-90 triangle. The first thing I do is draw a diagram. And then I would assign variables. I'll say, let one leg be equal to x, then the other must be, after all, the triangle's isosceles. Let the hypotenuse equal c. Notice I'm not writing a paragraph, you are. Then I would have to say, using the Pythagorean theorem, we're going to perform a substitution. So I'll replace x, x, and c. Now we can evaluate, we'll simplify here. I've got 2x squared equals c squared, and then I'll simply take the roots of both sides of the equation, and again we can factor the radical 2x squared into its components. Square root of x squared is x, and this is radical 2. So there you have it. The ratio of the sides is going to be 1, 1, radical 2.